When most of us look at the ground, we just see dirt. But what if I told you that right under our feet, there's a hidden world that's every bit as complex and alive as a rainforest? Well, today we're going to dig deep and uncover the secret life of soil, this incredible ecosystem that makes all life on land possible. So just keep that question in mind, okay? Because that's exactly the journey we're about to go on. We're going to travel from the very beginning, from lifeless rock, all the way to a bustling, microscopic world that's the foundation for literally everything we see around us. So where does it all start? I mean, before soil can be alive, it has to be made in the first place. So in part one, we're going to look at the raw, non-living ingredients. We're talking rock, weather, and time that lay the groundwork for everything else. It sounds pretty epic, doesn't it? But this question actually takes us right back to the very start of our story. See, a lot of soil begins as igneous rock, which is just cooled magma. And the way that magma cools, well, that's the first major fork in the road that decides what kind of soil it's going to become. Okay, check this out. When magma cools really slowly, way down deep inside the earth, it gets to form these big crystals. That gives you a coarse, kind of gritty texture. But on the flip side, when a volcano erupts and that magma cools super fast, the crystals are tiny, and you end up with a fine textured rock. This one single thing sets the stage for everything that follows.
So, we've got our rock. But a rock isn't soil, not by a long shot. It needs to be broken down, and the main player in that game is the climate, especially water. Let's dig into how that works.
Scientists have a name for the perfect soil-making weather, a humid period. It sounds technical, but it's really simple. It's just when there's more rain coming down than the sun and wind can dry up. And that leftover water, that's the secret sauce. It seeps into the rock, starts breaking it apart, and carries minerals around, basically jump-starting the whole soil-making process. So the main takeaway here is that making soil is a team effort. You need the right parent material, that's our igneous rock. You need relief, which is just the shape of the land, hills or valleys. And you absolutely need time, and lots of it. These are the big, non-living forces that get the ball rolling. All right, the stage is set. We've got our basic ingredients. And now, this is where the magic really kicks in. This is the point in our story where we pivot from just geology to biology. Once you have that foundation of broken down rock and minerals, the soil can truly come alive. And the heart of all that life, the absolute epicenter, is a place called the rhizosphere. The best way to think about it is like a super busy, microscopic city that springs up right around a plant's roots. It's a total hotspot of activity where the plants and gazillions of microorganisms are all trading resources. And get this, that city isn't just a cool metaphor. It's real, measurable science. Researchers can actually take the pulse of that zone using something called the RS ratio. It basically compares the microbial buzz right at the root to the quieter soil further away. So a higher ratio means that city is absolutely booming. So who exactly are the residents of this city? Well, a huge chunk of the population is made up of microscopic organisms, and fungi are some of the most important citizens. See, a lot of the nutrients in soil are locked away in a form plants can't use, but these fungi, they act like microscopic locksmiths, unlocking those nutrients for the plants.
Take phosphorus. It's absolutely vital for plants. This is where the whole system gets brilliant. Fungi like Aspergillus are total specialists. They release these special acids that dissolve phosphorus that's locked up in minerals, turning it into food the plant can absorb. It's a perfect partnership, right?
And this whole living ecosystem isn't static. It's not frozen in time. Just like any living thing, soil has a life cycle. It's born, it grows up, it matures, and it ages, and its personality totally changes over thousands of years. So let's just walk through these stages. It starts out as initial soil, which is barely more than weathered rock. Then life starts to move in, and it hits the juvenile stage. Over a long, long time, it gets deeper and more complex, becoming virile. And finally, it reaches the senile stage. Now, don't let that name fool you. It doesn't mean it's old and weak. It means it's fully developed, incredibly complex, and super rich. It's at its peak. Okay, so we've seen how soil is born and how it lives. Now, let's get practical. How do we actually work with it? In part 3, we're going to connect all these ideas to the real world, to farming, to gardening, and to how we manage this amazing resource. I mean, think about it. When we're farming, we're constantly making withdrawals from the soil's nutrient bank. So every now and then, you've got to make a deposit. A classic way to put back that critical phosphorus we were just talking about is by adding bone meal, which is made from, yep, exactly what it sounds like.
And man, is it effective. Bone meal is packed with about 20% phosphorus, and it's in a form that plants can just slurp right up. It's like giving the soil a massive power-up, recharging that nutrient bank. But nutrients are only half the battle. The most critical thing for any farmer or gardener is water. And not all soils hold on to water in the same way. There's this really crucial, kind of scary threshold called the permanent wilting point. It is literally the point of no return. It's when the soil is so dry that a plant will die even if you show up and try to water. This is where that soil texture we talked about at the very beginning comes back to bite you. You might think sticky clay is the best because it holds water, but it actually holds on too tightly, and plants can't pull the water out. The soil with the lowest permanent wilting point is actually sandy loam. Water just slips right through it, so it dries out the fastest. That makes it the most dangerous soil for plants during a drought.
And of course, soils get even more complicated. You've got some types, especially certain clays, that are a real headache, because they swell up like a sponge when they get wet, and then shrink and crack when they dry out. For these kinds of problem soils, engineers have to use special measurements, like the liquid ratio, just to predict how they're going to behave. So let's just bring it all home. We've gone on this incredible journey from a simple piece of volcanic rock to the buzzing microscopic city in the rhizosphere, and all the way to the practical challenges of gardening. The biggest thing to remember is this: soil is not dirt. It is a living, breathing foundation for everything on this planet. And so this whole journey leaves us with one final, really important question. Now that we've seen the unbelievable complexity and life teeming within the soil, what are we going to do to protect it? What's our role in making sure this essential living world beneath our feet has a future? That's something for all of us to think about.